Alright guys, so this week we're going to be applying our integrals to some word problems and seeing if we can't calculate some things, okay? So the way I use and think about applying integrals to these word problems is that the integral of a rate of change equals the total change. So the integral from a to b of some rate of change function dt, because normally we're talking about a time going from the time a to time b, is equal to the total change. For example, if I was to do like the integral from 0 to 5 of v of t dt. Now normally v of t is our velocity function, and so if, for example, t is in minutes, right? So if t is in minutes, then this we know is going to be equal to s of 5 minus s of 0, which, being a position function, s being position, we can see this is equal to the total change in position. In position from a time of 0 to a time that is t equals 0 to t equals 5. That's what this integral is going to be equal to. Or if you would rather call it, it is displacement from 0 to 5, okay? So we're going to be applying this, integral of a rate of change is equal to total change. So take a look at the first word problem here, okay? During spawning season, the rate of salmon swimming upriver is given by s of t equals, and then we got this function, for 0 to 28, where t is a number of days. Okay, always check out what your variables represent since the start of spawning season. So how many salmon swam up the river during the first 2 weeks? Well, the integral of s of t dt is going to be equal to your actual amount of salmon. So for 2 weeks, if this is in days, we're looking for the integral from 0 to 14. So in your calculator, put in 0 to 14. I'm not expecting you to do this one by hand. 1500 over 1 plus t minus 14 over 3 squared dt. If you calculate that up as I did, I got 6,118, and then a decimal, but we can chop this off because we're not looking for fractions of salmon right now. About 118 salmon in total swam up the river. Okay, you're going to have a number of problems like that. Let's take a look at one that includes a graph. So how about this top problem here? The graph above shows the rate of change in weight of an animal in ounces per week over a 30-week period. Which of the following is the closest to the total change in weight? So we're looking for the integral from 0 to 30 of this, let's call this capital R of t dt. Well, if this is our function, and this is a rate of change function, and we're trying to take the integral of it, well, that integral is also equal to the area. So essentially, what we'd like here is to know what the area is of all of this stuff here. And so I'm going to approximate that using just a rectangle, because the area in there in yellow is about 1/2 of the area going from 30 to 16, right? Length of 30, height of 16. Take half of that and you get about that yellow sliver, including this little portion down here, and that gives you 240. So it's about 240 ounces that animal increased in weight over the 30 weeks. Okay? And then finally down here, this is a chart type problem. Instead of giving you a function or graph, they gave you a table of values. It says fuel is pumped from an underground tank at the rates indicated in the table. Fuel is sold for $1.50 a gallon. Explain the meaning of the integral from 0 to 24 p of t dt. Well, since this is the rate that the fuel is pumped from an underground tank, this integral here is going to give us the total amount of fuel pumped in the first 24 hours. Or, of course, you could say in the first day. Okay? Now, if we wanted to calculate this integral using a table, it asks us to use a left-hand Riemann sum. So, and 6 subintervals. That's 1, 2, 3, 4, 5, 6. It looks like each one of these subintervals has an equal length of 4. So this is integral from 0 to 24 p of t dt is going to be 4 times. Now for each interval, it wants to use the left-hand values. So 4 times 250 plus 4 times 300 plus 4 times 400 plus 4 times 500 plus 4 times 200 plus 4 times 650, and that is our 1, 2, 3, 4, 5, 6 rectangles, which, calculating that one up, I ended up getting 9,200 gallons. Alright, so this takes us to the end of our first video on applications. My next video is going to be on average value of a function. Thank you.